Hi, I'm Mostyn. Today, I will explain the applications of derivatives to economics, then explain the virtual method to find the volume of a solid of revolution, finally explain the moment and center of mass. In fact, derivatives are helpful tools in economics to analyze how various economic functions change in response to changes in production. Then, let's begin with the applications of derivatives to economics. There are many applications in economics. Today, we will focus on the 6 basic aspects: cost functions, average cost functions, revenue function, average revenue function, profit function, and average profit function. Firstly, the cost function. A cost function represents the total cost incurred by a firm in producing a given level of output. It often includes both fixed and variable costs. It can be written as CQ equals to FC plus VCQ, where FC is the fixed cost and VC is the variable cost. The derivative of the cost function gives the marginal cost MC, which tells you the additional cost incurred by producing one more unit of output. It helps firms understand the cost implications of increasing production. If the MC is positive, it means the cost of production increases as X increases. This is typical as firms experience increasing costs with greater production due to factors like diminishing returns to scale. Otherwise, if MC is negative, it means the cost of production decreases as X increases. Actually, it is rare in real world economics of scale or decreasing costs due to technological advancements or efficiencies at higher level of production. If the MC is 0, then it indicates that the firm is operating at an optimal scale or at the lowest point on the cost curve. Then let's see an example. Suppose the total cost function is given by CQ equals to 100 plus 20Q plus 5Q squared. To find the marginal cost, we take the derivative with respect to Q. MC equals to dCQ divided by dQ equals to 20 plus 10Q. This means that the marginal cost increases with the quantity produced. If a firm produces 10 units of output, the marginal cost is MC equals to 20 plus 10 times 10 equals to 120. Then, let's see the average cost function. The average cost AC is the total cost divided by the number of units produced. It can be written as this form. The derivative of the average cost function helps us understand how average cost changes as output increases. If the derivative is positive, it means the average cost is increasing as output increases. This typically happens after the firm has reached its optimal level of production and is expressing these economies of scale. Otherwise, if the derivative is negative, it means the average cost is decreasing as output increases. This suggests that the firm is expressing economies of scale, where the cost per unit of output falls as production expands. If the derivative is 0, this is the point where the firm is most efficient in its production and it is producing at the lowest possible average cost. So average cost is a key measure of a firm's production efficiency. Then let's see the revenue function. A revenue function expresses the total revenue earned by a firm from selling its products. It is typically the price per unit multiplied by its number of units sold. It can be written as R equals to P times Q. The derivative of the revenue function gives the marginal revenue MR, which tells us the additional revenue generated from selling one more unit. If the derivative is positive, then it means the total revenue is increasing as output increases. It often happens when the firm is in a region of the demand curve where demand is elastic, which means a decrease in price leads to a larger increase in quantity demand. If the derivative is negative, then it means the total revenue is decreasing as output increases. It often happens when the firm is in a region of the demand curve where demand is inelastic, which means that the decreasing in price leads to a smaller increasing in quantity demands. If the derivative is zero, then it means the firm can no longer increase revenue by selling more units. This often occurs at the maximum revenue point. Let's see an example. Suppose the price function is PQ equals to 100 minus 2Q, meaning the price decreasing as more units are sold. The revenue function is RQ equals to 100Q minus 2Q squared. To find the MR, we differentiate the revenue function. We get MR equals to 100 minus 4Q. This shows that marginal revenue decreases as quantity increases, reflecting the price reduction required to sell additional units. Then let's see the average revenue functions. Average revenue AR is the revenue per unit of output, which is simply total revenue divided by the number of units produced. It can be written as this form. The derivative of the average revenue function gives insights into how the revenue per unit changes as output increases. If the derivative is positive, it means the price per unit increases as more units are produced. It is not typical, as it might only occur in a market where prices are raised due to limited supply or increased product differentiation. Otherwise, if the derivative is negative, it means the price per unit decreases as more units are produced. It is more common, so if the firm wants to sell more units, then it must lower the price per unit. If the derivative is zero, it often occurs in a perfectly competitive market where the firm cannot influence the market price. Then, let's see the profit function. A profit function represents the difference between total revenue and total cost. It can be written as PQ equals to RQ minus CQ. The derivative of the profit function gives the marginal profit MP, which indicates the additional profit from producing and selling one more unit. If the derivative is positive, it means the profit is increasing as producing and selling one more unit increases. It often occurs when marginal revenue exceeds marginal costs, when the firm should increase production to maximum profit. If the derivative is negative, it means profit is decreasing as producing and selling one more unit. This happens when marginal cost exceeds marginal revenue, when the firm should reduce production to maximize profit. If the derivative is zero, it means the firm has maximized its profit. Let's see an example. Just using the previous cost and revenue functions, we can get the marginal profit MP is 80 minus 14Q. Then setting marginal profit equals to 0 to maximize profit. So at Q approximately equal to 5.71, the firm maximizes its profit. Finally, let's see the average profit functions. The average profit AP is the total profit divided by the number of units produced. It can be written as this form. And the derivative of average profit indicates whether average profit is increasing or decreasing as output increases. If the derivative is positive, it means average profit is increasing as output increases. It often happens when the firm is experiencing favorable conditions and should increase output to benefit from these conditions. If the derivative is negative, it means the average profit is decreasing as output increases. It often happens when the firm is operating at a suboptimal scale or facing diseconomies of scale. If the derivative is zero, it means the average profit is maximized. This is the optimal level of production in terms of per unit profitability. Before introducing this method, let's first understand what is washer. Sometimes, slicing a solid of revolution results in discs with holes in the middle. We call them washers. There are two basic concepts, outer radius and inner radius. The outer radius corresponds to the distance from the axis of rotation to the outer curve of the region, and the inner radius corresponds to the distance from the axis to the inner curve of the region. Then, what is Virtual method? Virtual method can be written as this form, where Rx is the outer radius and Rx is the inner radius. A and B are the limits of integration corresponding to the range of the region being revolved. Then, let's see an example. The region is enclosed by the curves y equals to x and y equals to x squared. The region is rotated about the x-axis. Find the volume of the resulting solid. To find the volume, we can firstly find the area of the region. The area equals to pi outer radius squared minus pi inner radius squared. So, we should find the outer radius and inner radius. Let's look at the curve. We can easily get the outer radius equals to the x and the inner radius equals to the x squared. Then we can get the areas. Then, by using the Virtual method, we can easily get the final value of the volume equals to 2 pi over 15. Then, let's see the part 3, moments and center of mass. Moment is the product of the mass of a particle and its directed distance from a point. The moment measures the distribution of mass relative to an axis. The center of mass is the point on which a thin plate of any given shape balances. It is the weighted average position of the mass distribution. Let's see the graph. There exist two moments. Moment 1 equals to m1 times d1. Moment 2 equals to m2 times d2. And the center of the mass of a system of n masses located at n points along the x-axis is the total moment divided by the total mass. What's more, the center of mass of a system of n masses located at points in the xy plane is the total moment along the x-axis divided by m, and the total moment along the y-axis divided by m. Then let's see an example. The masses mi are located at the points pi. Find the moments mx and my and the center of mass of the system, where m1 equals to 4, m2 equals to 2, m3 equals to 4. P1 is the point 2 minus 3, P2 is the point minus 3, 1, P3 is the point 3, 5. Then we can easily get the total moment along the x-axis equal to 4 times 2 plus 2 times minus 3 plus 4 times 3 equals to 14. And mx equals to 4 times minus 3 plus 2 times 1 plus 4 times 5 equals to 10. And the total mass equals to m1 plus m2 plus m3 equals to 10. Then we can get the x equals to the total moment along the x-axis divided by m equals to 14 divided by 10 equals to 7 divided by 5, and the y equals to the total moment along the y-axis divided by m equals to 1. So the center of the mass of the system is the point 7 divided by 5, 1. That's all I want to say. Thank you for watching.